Let's say that I have a 100-meter long wire. So that is my wire right over there. And it is 100 meters. And I'm going to make a cut someplace on this wire. And so let's say I make the cut right over there. With the left section of wire, I'm going to obviously cut it in two. With the left section, I am going to construct an equilateral triangle. And with the right section, I am going to construct a square. And my question for you and for me is, where do we make this cut in order to minimize the combined areas of this triangle and this square? Well, let's define a variable that we're trying to minimize, or that we're trying to optimize with respect to. So let's say that the variable x is the number of meters that we decide to cut from the left. So if we did that, then this length for the triangle would be x meters, and the length for the square would be, well, if we use x up for the left-hand side, we're going to have 100 minus x for the right-hand side. And so what would the dimensions of the triangle and the square be? Well, the triangle sides are going to be x over 3, x over 3, and x over 3 is an equilateral triangle. And the square is going to be 100 minus x over 4 by 100 minus x over 4. Now, it's easy to figure out an expression for the area of this square in terms of x. But let's think about what the area of an equilateral triangle might be as a function of the length of its sides. So let me do a little bit of an aside right over here. So let's say we have an equilateral triangle. Just like that. And its sides are length s, s, and s. Now, we know that the area of a triangle is 1/2 times the base times the height. So in this case, the height we could consider to be an altitude. If we were to drop an altitude just like this length right over here, this is the height. And this would be perpendicular, just like that. So our area is going to be equal to 1/2 times our base is s, 1/2 times s times whatever our height is, times our height. Now, how can we express h as a function of s? Well, to do that, we just have to remind ourselves that what we've drawn over here is a right triangle. It's the left half of this equilateral triangle. And we know what this bottom side of this right triangle is. This altitude splits this side exactly into two. So this right over here has length s over 2. So to figure out what h is, we can just use the Pythagorean Theorem. We would have h squared plus s over 2 squared plus s over 2 squared is going to be equal to the hypotenuse squared, is going to be equal to s squared. So you would get h squared plus s squared over 4 is equal to s squared. Subtract s squared over 4 from both sides, and you get h squared is equal to s squared minus s squared over 4. Now to do this, I could call this 4s squared over 4, just to be able to have a common denominator. And 4s squared minus s squared over 4 is going to be equal to 3s squared over 4. So we get h squared is equal to 3s squared over 4. Now we can take the principal root of both sides, and we get h is equal to the square root of 3 times s over 2. So now we can just substitute back right over here, and we get our area. Our area is equal to 1/2 s times h. Well, h is this business, so it's s times this. So it's 1/2 times s times the square root of 3s over 2, which is going to be equal to, s times s is s squared, so it's going to be square root of 3 s squared over 2 times 2 over 4. So this is the area of an equilateral triangle as the function of the length of its sides. So what's the area of this business going to be? So the area of our little equilateral triangle, let me write combined area. And let me do that in a neutral color. So let me do that in white. So the combined area, I'll write it A sub C, is going to be equal to the area of my triangle A sub T, plus the area plus the area of my square? Well, the area of my triangle, we know what it's going to be. It's going to be square root of 3 times the length of a side squared divided by 4. So it's going to be square root of 3. Let me do that in that same yellow color. It's going to be, make sure I switch colors. It's going to be square root of 3 over 4 times the side squared times x over 3, x over 3, x over 3 squared. All I did is the length of a side is x over 3. We already know what the area is. It's square root of 3 over 4 times the length of a side squared. And then the length of, and then the area of this square right over here, the area of the square is just going to be 100 minus x over 4 squared. So our area, our combined area, maybe I could write like this, our combined area as a function of where we make the cut is all of this business right over here. And this is what we need to minimize. So we need to minimize that right over there, and I will do that in the next video.